Hello and welcome. Today we'll talk about some applications of trigonometric ratios in right-angled triangles. In other words, some applications of SOHCAHTOA. As you all know, whenever we're asked to solve word problems, very often we're required to draw a diagram. And drawing a good diagram is the best start to solving a problem. And to lead and help you to drawing a good and correct diagram, I want to go over a couple of definitions. Number one, the angle of elevation, and number two, the angle of depression. To illustrate this, I drew this diagram. So here is a giraffe. Her name is Sophie, by the way, and she is standing in front of a high-rise building. Now, if Sophie was to look straight ahead, let's make this straight, then we'll say that this is going to describe or represent Sophie's horizontal line of sight. And if Sophie decided to look up at the top of the building, right here, then we would say that this would represent Sophie's new line of sight. Now, the angle made between the horizontal line of sight and the new line of sight, when the new line of sight is above the horizontal, is called the angle of elevation. Why? Because she needs to elevate or to raise up her head or her eyes. So the line of sight is above the horizontal. Now let's say that Sophie decides to look down at the bottom of the building. So her new line of sight would be represented by this red line here. Now the angle made between the horizontal line of sight and her new line of sight will be this angle here. And guess what? We'll call this the angle of depression. Now sometimes you're going to hear the word declination. Declination, depression, or angle of declination or depression means the same thing. The same thing with elevation. So sometimes we use the word or the term inclination. So inclination for up, declination for down, or elevation for up, depression for down. It doesn't really matter. The meaning is there, okay? It's in English. Okay, the next thing is, what does it mean to solve a right angle triangle? Very often your word problems will say, solve this right angle triangle. And you say, like, so, but what do you find there? Well, what's to find in a right angle triangle? It's measurements. So what are the measurements of a right angle triangle? So the measurements are side lengths and angles. So to solve a right angle triangle means to find all the side lengths, and all the angle measurements. And when I say all, actually, there's only two angles we have to find, right? Basically, because we know one of them will be 90 degrees. Okay? So here we have our first example. In this example, we are given the triangle ABC, and we need to find the side lengths to the nearest tenth of a centimeter and angles to the nearest degree. So let's see what we got here. So we got a right angle triangle. We know this is 90 degrees from the square. We know two side lengths. We don't know any of the angles or the sides. So I will make a decision and I will decide to solve for the angle A first. And since I'm trying to find angle A, I will label all the sides in the triangle in relation to angle A. So this side here is always the hypotenuse, no matter which angle we are referring to. That's because it's opposite the 90-degree angle. And this side here would be the adjacent because it's the other arm of the angle. And last but not least, I'm going to write adjacent here. And last but not least, we have the opposite. And now we're thinking, if I want to find the angle A, what are my options here? What side lengths can I use? Well, I can use the ones given, right? And what I'm given is the adjacent and the hypotenuse. So I'm going to write this down for now. So to find angle A, you don't have to actually to use these kind of explanations normally on a test. So we have to use adjacent and hypotenuse. And then we have to think, where do we see adjacent and hypotenuse sitting next to each other in our famous SOHCAHTOA formula? And I write this down just for the fun of it whenever I'm doing homework or practicing. So I see adjacent and hypotenuse. Let's take a look, not in sine, but in cosine. So I'm going to say that means I must use the cosine ratio of angle A. So we'll write down here that the cosine of angle A equals the adjacent over the hypotenuse. And with adjacent of 11, hypotenuse of 13, we'll say cosine of angle A is 11 over 13. How about angle A? Well, that would be inverse cosine 11 over 13. Let's use the calculator. As always, make sure your calculator is on degree mode. And I will have to press second. Sorry, I'll clear everything. So second cosine 11 divided by 13. I've already set my calculator on degree mode. Make sure 32.2 it says. And our question is asking to round to the nearest degree. So angle A is 32 degrees. That's it. So we got angle A. And whenever I find a measurement, especially when I solve geometry problems, I like to write them on the diagram. The reason why is because it's better to see all the numbers working together with the diagram. It gives us a better view of what we have and what we need to find. So the next thing that I want to do, and since we're talking angles, is find out the other missing angle, the angle C. So to find angle C, you can use SOHCAHTOA for sure. But why bother and, use the ratios and relabel the sides in the triangle? We can also find the angle C by using the sum of interior angles in a triangle, right? So that's 180 minus 90 minus 32. And some people just like to write 90 minus 32 because they know 180 minus 90 is 90, right? And you take away the angle. Remember that in right angle triangles, these two acute angles are complementary. Complementary means add up to 90. So we're going to say that angle C equals 90 minus 32. Let's see who did that faster. So that would be 58 degrees. Okay. So here we are. I'm going to box this up. And so far, I found all the angles actually in this triangle. So proud of myself. See? And I need to find one last thing, which is this side in here, the opposite side to angle A. And I don't want to change the labeling, so I'm going to keep the same diagram. So to find the opposite, I have to think this opposite is opposite to 32. And I can use either the side 13 or the side 11, so either adjacent or the hypotenuse. So to find the side length, okay, we are going to either use adjacent, so the side length BC is an opposite side, right? And we have to choose what ratio to use. So I can use the hypotenuse just for the fun of it, and if I use the hypotenuse, that means that I have to use the sine ratio of the angle 32. And the sine of 32 equals opposite, which we don't know, over hypotenuse, which is 13. So sine 32, in other words, is equal to, the opposite is the length BC over 13. Remember what we have talked about using this bar for lengths of line segments? So remember, this is a fraction with denominator 1 as well. And remember, cross multiplication when you have a fraction in each side of the equation. And then we'll get 13 sine 32 equals BC times 1. That will make the length of the side BC equal to 13 sine 32. Nice numbers, 13 times sine 32. Now, one thing I want to remind you of is better to put the number first and then multiply by the sine of the angle. Why is that? Very often, people forget to close the brackets of sine 32. That will make the angle so big. 6.888. Round it to one decimal, 6.9. 6.9 centimeters. And here we go. This is the last measurement we had to find. And with this, we're going to say that we have solved the right angle triangle. Let's see what we have.